Thanks for joining me today. In this lesson, we are going to be talking about how to find the area of a trapezoid and of a rhombus and of a kite. So first of all, if you will recall, the definition of a trapezoid is a quadrilateral with exactly one pair of parallel sides. So here we have a picture of a trapezoid right here. So these are your parallel sides, and then this is the perpendicular height. Now the formula for the area of a trapezoid is area equals 1/2 times the height times the sum of the bases. And we want to add the bases first and then multiply it times the height and then take a half of it. Remember, your height is your perpendicular distance between the bases. All right, so here's an example. Find the area of the figure. Well, because these are both right angles, we know that we have parallel lines, so these are your bases right here, the 6 and the 8. So start out by writing the formula, the roadmap to the way that we do the assignment. So it's 1/2 times the height times the sum of the bases. So base 1 and base 2. And now, once you do that, you only have to fill in those values and multiply it out. So the height is the perpendicular distance between the bases, and that would be 4. And then the bases, the sum of the bases would be 6 plus 8. So 1/2 times 4 is 2, and 6 plus 8 is 14. So you get 28. And that would be area, which is in its feet, so it's feet squared. Okay, next one. The free throw lane on an international basketball court is shaped like a trapezoid. So here we have a trapezoid, parallel sides here. Find the area of the free throw lane. So we want to find the area of the trapezoid. So again, area equals 1/2 times the height times the sum of the bases. All right. When we say height, remember that means the distance, the perpendicular distance between the bases. So that would be 5.8. And then the bases are 3.6 and 6. So these are your bases. And now we'll put that in a calculator. My calculator disappeared. Here we go. And if you have a calculator that will do parentheses, use those parentheses. Otherwise, you need to simplify this sum first, because of PEMDAS, we have to do the parentheses first. So 3.6 plus 6 is 9.6. So you can just go ahead and multiply these three together, or at this point right here, just type it in the way you see it, parentheses and all. And your answer should be 27.8 approximately. And that would be meters and squared because it's area. Next, find the area of the trapezoid. All right, so this one is a little bit different than the last one because we don't have the height. We have the two bases, the 5 and the 7. So we have to do a little work here for that. Now, let's see. We have a triangle, and it's going to be a right triangle, so we could use some trig. Now, if from the distance from here to here we know is 5, and the whole thing is 7, then we know that this distance is 2. And we're looking for this right here, so let's use trig. You could use your 30, 60, 90s, but I like trig. So let's label our sides. This is the opposite. This is the adjacent. So think about SOHCAHTOA. So opposite and adjacent, that would be tangent. So the tangent of 60 equals h over 2. So h equals 2 tangent of 60. Which is 3.5 about. All right, so find the area of the trapezoid. Area equals 1/2 times the height times the sum of the bases. All right, now we just have to fill in those values. The height is 3.5, and the bases would be 5 plus 7. So that's 1/2 times 3.5 times 12. And that gives you 21, and that would be meters squared. All right, next, rhombus, a parallelogram with 4 congruent sides. So remember, that's a parallelogram with 4 congruent sides. So the area of a rhombus, the formula is 1/2 diagonal 1 times diagonal 2. So when you have a rhombus, remember all the sides are congruent. If it's a rhombus, a parallelogram with 4 congruent sides, the area would be 1/2 times diagonal 1 times diagonal 2. Next, we're going to look at a kite. A kite, remember, is a quadrilateral that has 2 pairs of consecutive congruent sides, but opposite sides are not congruent. So the area of a kite, so write that down, is 1/2 diagonal 1 times diagonal 2. So these formulas are the same. So when it's a rhombus or a kite, the formulas are 1/2 diagonal 1 times diagonal 2. Rhombus PQRS represents one of the inlays on the guitar in the photo. Find the area of the inlay. All right, so this problem, what we're doing is we're looking at this picture right here, and they're taking that out, and this is what one inlay looks like. And so this, because all the sides are congruent, is a rhombus. So the formula for the area of a rhombus is 1/2 times the length of diagonal 1 times the length of diagonal 2. All right, so this would be one of the diagonals. And if this side is 12, that means this is 12. So the whole diagonal is 24. And if this is 9, then this is 9. So this diagonal is 18. And then you multiply it together. So 24 times 18, and then I divided it by 2. You get 216, and that would be area, millimeters squared. All right, here's another one. This time we have a kite. So again, find the area, 1/2 D1 D2. Okay, so one of the diagonals is 6. The other one is this length, which is 14. And that gives you 42. Next one is a rhombus. Again, 1/2 D1 D2. So from here to here is 40. That means this entire diagonal is 80. And if this is 30, the whole thing is 60. Whoopsie, sorry, that's 1/2. All right, so 1/2 times 60 times 80. And I get 2,400 meters squared. Square meters. Okay, the next one. One diagonal of a kite is twice as long as the other diagonal. The area of the kite is 72.25 square inches. What are the lengths of the diagonals? All right, so first thing I'm going to do is draw a picture of a kite. Okay, not the best kite, but it'll work. Here's one diagonal, and here's the other one. So it says one diagonal is twice as long as the other diagonal. Well, this diagonal is going to be x, which means this one would be 2x because it's twice as long. So now the next thing I do when I'm solving problems like this is I write the formula, 1/2 D1 times D2. And then fill in everything you know. Area, it says, is 72.25. And then we have times 1/2. The first diagonal is x. The next one is 2x. I'm going to write this over 1 and this over 1. So what we have is 72.25. And if we multiply across on the numerator 2x times x is 2x squared over 2. Couple ways you could do this. You could get rid of the fraction by multiplying both sides by 2, or you could say, well, this is 2 over 2 right here. So 72.25 equals x squared. And then remember, to solve that, we take the square root of each side. So the square root of 72.25, so x is equal to 8.5. And that would be your answer. And you can plug that in and make sure that works. 8.5, and then this would be 17. And if you multiply that together, divide by 2, it should be 72.25. All right, so here are a few more problems. I have a kite. So area equals 1/2 d1 times d2. All right, this diagonal is 16 plus 30. So this diagonal would be 46. From here to here is 16 plus 30, that's 46. We do not have any lengths for this diagonal. Now, the thing that we need to remember to help us solve this problem is that when you have a kite, one of the properties is that the diagonals are perpendicular. So we have a little triangle right here, and this side is 16, this is 20. We have some options. Well, I guess we don't have options, but we can use a Pythagorean theorem. That's the way that we would solve this problem, because it's a right triangle. And so the hypotenuse is the c, that's the 20. So c squared equals a squared plus b squared. And then we will plug in the values. 20 squared equals 16 squared plus, and we'll put in x squared. So that would be 400. And that would be 256 plus x squared. And we subtract 256. And we get 144. And to find x, we'll take the square root. X equals 12. So this length is 12, which means this is 12. Because remember, this segment gets bisected in a kite. And so the length then of this diagonal would be 12 and 12, which is 24. And now we're in business. So 1/2 times 46 times 24 gives you 552 units squared. Okay, here's another one. Now we have parallel sides, one set. So this is a trapezoid. Now, the problems are getting mixed up here. So the area of a trapezoid is 1/2 times the height times the sum of the bases. Okay. So we will have, let me see here, 1/2, and we don't have the height here again. So we are going to need to use the Pythagorean theorem once again to find the height, and we'll put that right here. And then the bases would be 9 plus 11 is 20 plus 8. So I'm not going to finish working this, but this is Pythagorean theorem. So this would be your c squared. 15 squared would equal 9 squared plus x squared. And if you solve that, you'd find x, and then you put it right here. In the next one, we are missing one. This is a trapezoid again, and we're missing one of the bases. So to do this problem, let's actually work this one out. Let me see here. So this side is 20. And we have to find this length right here. Now here's the thing. You know that this is 21. So once you find what x is, you can add that to 21 to get this base. So let's do the Pythagorean theorem. This would be the c. So c squared equals a squared plus b squared. So 29 squared equals 20 squared plus x squared. And that would be 441. I skipped some steps there. So 29 squared minus 20 squared is 441. And if you take the square root of 441, you get 21. So this is 21 also. Doesn't really look like it's halfway, but my line's not real straight. So to solve that problem, we have the area equals 1/2 times the height times the sum of the bases. So it would be 1/2. The height is 20. That's the perpendicular distance between the bases. This base is 21. This base would be 42. And so we would have 630 square units is what I come up with. All right, let's see what's next. So we are going to be, you're going to do an assignment on that out of the book. And then tomorrow you're going to be doing a worksheet. And on the worksheet, I'm going to go through and do some of the problems for you. So let's get to a pen. Sorry. Okay. Now, here's the big thing with this. Write the formula down. So first of all, we have the area of a parallelogram. We'll do this one. Would be base times height. The base, let's see, these two sides are 12. So your base is 12. Your height is 6. 12 times 6 is 72 units squared. All right, next we'll do, oh, come on board. Next we have an area of a triangle. That's 1/2 the area of the base times the height, or base times height divided by 2. So here, your base is 7, and your height is 6. So that would be 42 divided by 2, which is 21 units squared. All right, next we look and see what type of polygon, we decide what type of polygon we have here. This first one, we have parallel lines, so that's a trapezoid. So the formula is area, my pen is starting to act up here. Area equals 1/2 times the height times the sum of the bases. So these are your two bases, and that's your height. In this next one, we have a kite. So that's going to be area equals 1/2 d1 d2. This diagonal would be 8. So this would be 8. And this diagonal from would be 4 plus 8, it would be 12. You have to add those together. 4 plus 8 is 12. All right, in this next one, we have a couple of polygons that are actually put together. So we have to find the area of each of them and add them together. So you have a rectangle on the bottom. So it's just going to be base times height, 18 times 6. Find that area. Now if this is 18, this is 18. Here you have a triangle. So let me write this down. Area equals base times height. Area equals 1/2 base times height. So this base is 18. The perpendicular height is 6. So find those areas, add them together. This one too is a triangle, and so the base for the base, you're going to have to add those together. That would be 36. And here we're going to have to do the Pythagorean theorem to find the height. Okay, next page. Find the area of the rhombus or the kite. So let's see, let's do this one. Area equals, it's a kite, 1/2 d1 d2. So this diagonal would be 10, 5 and 5. This one would be 16, and so that would be 80. Okay, so let's get into some of these problems right here. You have to find the value of x. Now, here's the important thing. Write the formula and fill in what you know and solve the equation. So we'll do this one. So this is a parallel, or excuse me, a rhombus. So it's 1/2 times the height times the sum of the bases. So 1/2, oopsie, we know the area is 196. And the height is x, and the bases are 21 plus 28. So that's 196 equals 1/2 x, and 21 plus 28 is 49. All right, so what I do with this always is get rid of that fraction. So you're dividing by 2. I would multiply both sides by 2. So 196 times 2 is 392. And 2 times 1/2, that cancels. And this would be 49x. So then you just divide both sides by 49. Yep, my pen is tired. So 392 divided by 49 is 8. And that's your answer. So with these problems, write down the formula and plug in what you know. Okay, thanks for watching today, guys. Have a great rest of your day. Let me know if you need help.